So here we go, number 53 in section 5.3, we're just going to practice. These are our tangent identities. We're just going to practice them. The tangent of a sum. So let's see, and a difference. So this is an identity much like you just did on your quiz. Your job is to change one side into the other. Alright, so let's make sure I copied it right. Okay. Now, would you agree that you have an identity for this? You have something that you can expand this, write this out as. What is the tangent of x plus y? Just this part right here. What is the tangent of x plus y? Tangent of the first plus tangent of the second, good, over 1 minus tangent of the first, tangent of the second. So that, right there, that big fraction, is this guy right here. Now we're going to multiply him by this. Now, we have a formula for that too, don't we? What's our formula for that? It's just like this one, the signs change. So it's tan of the first minus tan of the second over 1 plus tan first, tan second. Remember, with all of your sum and difference identities, like sine A plus B, sine A minus B, they're the same except for the SIGNs, right? Same thing with the tangent. These are exactly the same except their SIGNs are switched. Okay, all right, what next? Okay, so that's my formulas. All right, what might we do now?
This is the 5.3.
Multiply. Yeah, these guys need to be multiplied, and be careful, top times top, that's how we multiply fractions. So won't that be a FOIL up there? Yeah. And if you're really on top of things, you notice, okay, wait a minute, this is tan plus tan, and that's tan minus tan. Isn't stuff going to cancel out when I FOIL? Because it's like the difference of squares. So I'm going to end up with tangent squared x minus tangent squared y. Now, I've done hundreds of these, so that makes sense to me. If it doesn't make sense to you, FOIL it out. First, outside, inside, last. FOIL it out, and this is what will happen. All right, now, don't we have to do the same thing on the bottom? Yeah. This is, you're multiplying this denominator times this denominator. So that's another big FOIL. But is it kind of the same situation? So when I do that big FOIL, first, outside, inside, last, I'm going to end up with 1 minus tan squared x, tan squared y. 1 times 1, outsides and insides are going to cancel, and I'm going to have this time, last times last, which is going to give me that. And guess what? We're done. That was easy. That was easy, wasn't it? Yeah. Yeah. Okay, so that homework problem's done. Now, Katie has found another homework problem, so let's do another one. We need to know page number or section number or something.
5-3.
Okay, we're on 5.3, right where we've been.
I just don't, yeah, we're supposed to do for 25.
Okay, I'll do one of them. So I'll do 23. Is that okay?
Yeah.
All right, so I'm doing the sine of x minus 90. I'm going to go ahead and change my pi over 2 into 90. And you are verifying this. You're proving it. So in other words, you're going to change this side into this side problem. I mean, go either way, but that's what I would do. Do I have a formula for this?
Yes.
Okay, so that says sine of the first cosine of the second minus cosine of the first, sine of the second. All right, we got to get familiar with our identities now. Sine, because we're getting more today. We're getting new ones today. This is the last batch for a while that we'll get today, but we're getting some more today. So we gotta know our sum and difference identities. So this is a sign of a difference. So it's sine of the first, cosine of the second, minus, because in the sine formulas, the signs stay the same, and then cosine of the first, sine of the second. Okay. Now we've done problems where once we've gotten this expanded, we've had to figure out 4 different numbers, right? There's sine x, there's nothing to do with, but what about cosine 90? Can I find the cosine of 90? Yes. What's special about 90?
It's on the axis.
90 is up here, right? Which is what point? 0, 1. So x is 0, y is 1, and r is 1. So what's the cosine? I need the cosine, which would be x over r, which is 0. Cosine x, can't do anything with that, but what about sine 90? What's the sine of 90? Y over r, which is 1. Now, what happens when I multiply these two together? Sine x times 0. It's gone. And here, I'm just going to be left with negative cosine x, which is what we wanted. Right?
But isn't that like opposite of cofunctions too? If you prove it by like that, so just instead of 90 minus x, it's x minus 90, and you can prove that because the cofunction.
Okay, now this is not a cofunction identity. A cofunction identity would be 90 minus x. So you'd have to use a combination of a cofunction identity and an odd even identity. And by the time you did that, it's probably just easier to do this. But yes, absolutely. This is not a cofunction identity. I want you to remember, cofunction identities are 90 minus, not minus 90. Okay?
Can you do number 7?
Okay, this is the last one, number 7. Number 7's, I'm going to change that into degrees. So 7 pi over 12 would be what? 75. So I'm going to find the tangent of 75 degrees. Now, 75 is not special. What do I mean by that? When I say 75 is not special, what do I mean? It's not if I draw it, it doesn't produce a 30, 60, 90 triangle or a 45, 45, 90 triangle, right? That means it is not special. However, it can be broken down into special angles, and I heard somebody say 45 and 30. Certainly, there are other ways to break it down. You do not have to use 45 and 30, but I think that's probably the most obvious, easiest one. Okay? So, what's my formula when I have to do the tangent of a sum? I just erased it here with x's and y's. What is it? Tangent of the first plus tangent of the second over 1 minus tangent of the first, tangent of the second. So now I'm right back where I was with Katie's problem. I got to plug in some numbers now. The numbers I'm going to plug in are the tangent of 45. So I'm going to draw my 45 degree angle and the tangent of 30. So I'm going to draw my 30 degree angle. Now I don't have to worry about anything being negative because 45 and 30 are both in quadrant 1. So everything's going to be positive. Okay, so here we go. What's the tangent of 45? Look at the picture you drew. The tangent of 45 is 1. What's the tangent of 30? 1 over root 3, but I think I'll put that in as root 3 over 3. Over 1 minus root 3 over 3. Because it's 1 minus 1 times root 3 over 3. Is that okay with everybody? Alright, now that's a mess. We got complex fraction. That is, we have a big fraction with 4 little fractions in it. What's the common denominator of all those little fractions? 3. So I'm going to multiply everything by 3. Now, that's the way Mrs. Ford cleans up her complex fractions. You can do it other ways, but not as easy as this. This is the easiest way. Multiply everything by 3. So what do I end up with if I multiply everything by 3? 3 plus root 3 over 3 minus root 3. Now we've got a radical in the bottom. That can't be there. So we're going to multiply, like Christina said, by the conjugate of the bottom, which would be 3 plus root 3. Right? And now we just FOIL all over the place. So first, outside, inside, last. And first, outside, inside, last. Remember, when you multiply root 3 times root 3, you just get 3. Now, hopefully that fixed the problem. Did that fix the problem? Yep, your denominator is just 6. And what's our numerator? 12 plus 6 root 3. Oh my gosh, we're still not done. You can take a 6 out. Remember, you don't cancel unless you can factor. You can factor a 6 out. So out comes a 6, and I'll be left with 2 plus root 3. Now the trigonometry ended right here. All the rest of this stuff is just the arithmetic we have to do to make our answer presentable. Okay? Unfortunately, every time you do a tangent problem, that's going to happen. Every time. You're going to have to go through all those steps. That's the way it is. All right. All right, I want to do one more quick review with the sum and difference. Actually, 2 more. Quick review with the sum and difference. And then we're going to forge ahead into our last set of basic identities. And those are the half and double angle identities. But let's try this first. Cosine 58, cosine 12, minus sine 58, sine 12. What if you found this laying out the hallway? You would pick it up and get so excited because this is what? This is the cosine of 70. Very, very good. You guys that are on top of things recognize cosine, cosine minus sine, sine is a cosine identity. With the cosine formulas, the signs are different than the problem. So since that's a minus, this will be a plus, and my U and V, or A and B, or X and Y, alpha, beta, whatever you want to call them, are 58 and 12, so that's the cosine of 70. Okay? Got to be able to do that. Got to be able to recognize the formulas. What are the patterns again? The cosine pattern is cosine, cosine minus sine, sine. What's the sine pattern? Sine, cosine, plus or minus, cosine, sine, right? And then the tangent one's pretty obvious. It has tangents in it. Tan plus tan over 1 minus tan. All right, good. The other, another problem, one last problem about this. What if I told you that the secant of P is 13/5, and P is in quadrant 4, and the cosecant of Q is 5/4, and Q is in quadrant 2, and ask you to find the sine of P plus Q. Now, when you see this, the sine of P plus Q, what pops into our head? The sine of U plus V, the sine of P plus Q. What do we know? What do we have here? Sine P cosine Q plus cosine P sine Q. So that's the formula we know we're going to use. When you see sine, cosine, tangent, U plus V, U minus V, you got a formula immediately. Go there. Where am I going to get the numbers that have to be plugged in here, though? To get an answer, I'm going to have to plug in some values. Where am I going to get those values from? The given? Antonia?
Well, if we know that secant is technically 1 over cosine, then wouldn't it be 5 over 13 equals cosine P?
Exactly. So I'm going to draw that down here. There's my cosine. This is a picture of P. There's my cosine. So I'm going to need my sine too, Antonia. So I'm going to get my opposite side with the Pythagorean theorem. And it's going to be negative because of where it's located. So now you're right. There's P. My sine is 12/13, and my cosine, as you indicated, was 5/13. So P is done. I filled in my P numbers. Now let's do the same thing with Q. Q's in quadrant 2, and the sine would be 4/5, because the cosecant was 5/4, which means that this side, by the Pythagorean theorem, is 3 negative, because of quadrant 2. And now I can fill in, okay, the cosine of Q and the sine of Q. And I'm ready for my answer, which would be what? 36/65 plus 20/65, 56/65. Everybody okay with that? Alright, let's do just one more and then we will forge ahead, I promise. So let's try this. I'll use this side. Let's do cosine. What if I ask you to simplify this? What if the directions just said simplify? What would you do? Okay, I'm going to say it again. Whenever you see sine, cosine, tangent, and then a sum or a difference, you've got to think about your U plus V. You've got to think about those U plus V formulas down there, okay? So this is a cosine, and that's a minus problem. So what's popping into my head? Cosine 270. Cosine theta. Plus sine 270, sine theta. Perfect. That's what's there. Immediately, that's where you go when you see that identity, or that situation. You got a function, and then a plus or a minus. You're going to go straight to the identity. Now, just like over here, we've got 4 slots. In this problem, we're not going to be able to fill in this slot. Cosine theta, we're not going to be able to fill that in because we don't know anything about theta. We weren't given information. But what about cosine 270? Can I fill in that value? And how will I do that? I will go to my circle and look down here at 270. What's that point down there? Radius is 1. What's that point? 0, negative 1. So x is 0 and y is negative 1. So what's the cosine? Cosine x over r. So that would be 0. What's the sine down there? The sine of 270? Negative 1. It's y over r, so it'd be negative 1. So what does this simplify down to? Your job was to simplify it. What does it come out to equal? Just negative sine. Yep, negative sine theta. Okay. All right, if you turn your green sheet over, you see the very last set of identities or formulas, theorems, whatever you want to call them. They're called the sum or the double and half angle identities because they allow us to deal with not the sum and difference, but with things like sine 2x and cosine x over 2. All right, so let's talk about how those work. The double angle identities are the easiest to work with. The halves get a little bit tricky, and you'll see what I mean in a minute. But let me just set up a problem for you and show you an example of a kind of problem you're going to have to be able to do. Let's say here's the given. Tan x equals negative 3/4, and x is in quadrant 4. And your job, we'll just do these two problems right here. We'll just find those two things. So knowing, having never done one of these in your life, but having done other stuff leading up to this, what might you do? If you have to write down something, what might you do with this setup here? Let's just focus on problem number 1 right now. So you got this given, and we're doing this problem. What could you do? What occurs to you? Maybe I should do this. Draw it. Absolutely. Draw a picture. Draw a picture. Because when you choose a formula to use, you're going to have to plug numbers into that formula, just like we've been doing. And where are those numbers going to come from? They're going to come from the given, which is the tangent 3/4. Pythagorean theorem would say the hypotenuse is 5, down there in quadrant 4. So there's the picture of the given. Would everybody agree with that? Now, what about sine 2x? You got your green sheet in front of you. What do we know about sine 2x? It's 2 sine cosine. Very easy to work with, 2 sine cosine. So now I need to plug in a couple of numbers, right? And I'll get those numbers where I always get them for my picture. So what's the sine? Negative 3/5, and the cosine is 4/5. Now when we multiply this, remember it's 3 fractions times each other straight across. So the answer will be negative 24/25. That's all there is to it. That's it. So what did we do? Nothing different. The only thing that was different was we used a different formula. Other than that, it's exactly the same. Draw a picture, write out your formula, plug the numbers into the formula. That easy. Okay, now, let's do problem number 2. It's the cosine of the half angle. Now, I don't need to redraw my picture. It's the same given, so my picture's good. But now I need the formula for the cosine of the half angle. Okay, what is that? Look at your green sheet. Half angle identity. What's the cosine version? Plus or minus the square root of 1 plus the cosine over 2. So here's the formula. There's my picture, so I'm just going to plug the numbers in. So what's that going to say? All I have to do is plug in cosine, so it's going to say 1 plus 4/5 over 2. Now, you have to clean that up, and again, I don't care how you clean it up. I'm going to multiply everything by 5, because that's what works for me. And I can do it in one step without rewriting a bunch of stuff. So I end up with, on top, what? What do I end up with up here? 5
plus
up with plus or minus the square root of 9/10, which is plus or minus the square root of 9 over the square root of 10. Which is plus or minus 3 over the square root of 10. Which is plus or minus 3 root 10 over 10. Okay, everybody follow all that? There's my formula. Plugged 4/5 in for the cosine. Cleaned it up, got 9/10. The square root of 9/10 is 3 over root 10, which is 3 root 10 over 10. Now you got to decide, do you want the positive or the negative? Now I need you to pay real close attention. This is the tricky part. It's real obvious, but sometimes we don't think it through. If X is in quadrant 4, tell me the boundaries for X. In other words, X is between what and what if it's in quadrant 4? 270 and 360. That was given, right? Now my question is, though, where is X over 2? So if X is between 270 and 360, then half of it will be between 135 and 180. Would you agree with that? Which means this angle, the one I'm interested in, is in which quadrant? 2. I am concerned with the cosine in quadrant 2. What do we know about the cosine in quadrant 2? It's negative. So we are going to choose the negative root. What a lot of times kids will do is look at this and say, oh, that's quadrant 4, cosine's positive. But X is in quadrant 4. You need to figure out where half of it is when you choose your sign.
Is it possible to get an imaginary number?
No. All right, ready to try another one?
Yeah.
Yeah, I love it. Yeah, she says, with great enthusiasm. Everybody else is trying to watch the clock. Oh, when do I get out of here? All right, let's try another one.
They really need to do
Don't get excited. You have to stay. All right, so the given is, let's say the secant, I'm trying to use numbers that have decent outcomes instead of crazy radicals and everything. So let's say the secant is negative 13/12 and we'll be in quadrant 2. Oh, let's put it in 3. And we want to find, we'll make this a 2-part question again. We want to find the cosine of 2x and the tangent of x over 2. So using, or not a, I should use the a, sorry. 2a and a over 2. All right, so there's our given. So I think I'll just draw a picture of that right now. I'm in quadrant 3, and the secant is 13/12. Make sure when you draw that picture that the negative does not go on the 13. So this side would be negative 5. Are we ready? All right, cosine 2a. Look at your sheet. You've never seen these before, never used these before, so you've got to look at the sheet to get the formula. How do you know which one to use? Because the cosine has 3, doesn't it? Now, I'm going to step over here a minute and explain to you what's going on. The main one, and should be the first one listed, is cosine squared minus sine squared. Now, don't get that confused with an identity you already have. You have one already that says cosine squared plus sine squared, and that equals 1. This is different. This is cosine squared minus sine squared. This identity, this version of the identity, will work in every single problem. So if you're going to memorize just one of the 3, then memorize this one. Okay? This is the standard. However, because of that identity that says sine squared plus cosine squared is 1, we know that sine squared equals 1 minus cosine squared. We've used that in problems, right? Taken out this, in fact, some of you on your identities quiz needed that. Take out sine squared and replace it with 1 minus cosine squared, or vice versa. Cosine squared is 1 minus sine squared. If you take this identity and, let's say, take out the cosine squared and replace it with 1 minus sine squared, look at what happens. You end up with 1 minus 2 sine squared, and isn't that another one of your formulas? If you replace this one, you end up with 2 cosine squared minus 1, which is your other formula. So these are just versions of this one with these substitutions put in. So the question is, how do I know which one to use? Well, it never really makes any difference. In this problem, though, I probably would do 2 cosine squared minus 1. Because what was given to me in the given? What was given? The secant? And if I know the secant, don't I automatically know the cosine? So I really don't even need my picture if I use this identity. If I use the other one, if I do cosine squared minus sine squared, it's fine. But I don't know what the sign is. They didn't tell me what the sign is, so I'm going to have to get that from my picture. It doesn't matter. You're going to end up with exactly the same answer. Either one's going to work for you, so let's work it out and make sure I'm not lying to you. What's negative 12/13 squared? 144 1/69. So that would be 288 1/69. Remember, when you multiply this times 2, it's like 2 over 1. And I got to subtract 1, which means I need a common denominator. And what's that going to equal? What's 288 minus 169? 119. All right, that's what I got when I did this one. Let me see if that's what I get down here. Yep. So I just did it twice. You don't need to do it twice. Pick an identity and go with it. Doesn't matter which one you pick. Sometimes one's a little easier than the other, but in the end, it doesn't make any difference. You all right with that? All right, then let's do the tangent one. I'm going to erase all this stuff. What's our formula? We're going to use the same picture. There's our picture right there. What's our formula for the tangent of the half angle? There's 3 of them there too, aren't there? Now, I am going to use the first one because I want to practice again with the sign thing, the plus or minus. But then we'll do it using the other one and see how much easier it is. But I want to practice with this one. Because with the cosine and the sine, you don't have an option. So you're going to have to do this formula, so I want to practice with it again. So here we go. What is it, and for the radical one? What is it? 1 minus cosine over 1 plus cosine. Says that right there on your paper. So here we go. We're going to do it using one of the other ones too. But again, I don't know what your capacity for memorization is. Alright, so here we go. 1 minus cosine would be what? What's cosine? So that'd be 1 plus 12/13 over 1 minus 12/13. Because the cosine is a negative number. So since it's negative 12/13, 1 minus a negative is 1 plus, and 1 plus a negative is 1 minus. Alright, so I'm going to multiply everything by 13. Again, you can do whatever you want, as long as you get it cleaned up. So I get 13 plus 12 over 13 minus 12. Oh my gosh, what is that? That's just 25, isn't it? So my answer is plus or minus 5? The original is between what and what? The original. 180 and 270. So half of it is between 90 and 135, which puts it in quadrant 2. Is the tangent, this angle is in quadrant 2, is the tangent in quadrant 2 positive or negative? Negative. So once again, we want the negative answer. Now, if you have your other identities memorized, let me do this again with one of the other identities, because the tangent half angle has more than one. Which one did you suggest, Zach? For this problem, Zach Elson, which one did you suggest we use? And which is what? I don't have these memorized, so I need your help, Zach. So that's what it is. All right. So then, notice, what does that not have? A radical with that plus or minus thing. So the answer is just going to come out, hopefully. Let's see. What's the sign of this angle? Negative 5/13 over 1 plus, what's the cosine of this angle? Negative 12/13, so I'll make that minus. So I'll multiply everything by 13 again. And what do I end up with? Negative 5 over 13 minus 12, which is negative 5. Same thing we got me with the other way. So, much faster for sure, easier, but the trade-off is it's one more thing to memorize. But you can. Absolutely you can. Use it. It works. Alright, everybody okay with that? Alright. And I'm going to introduce one more kind of problem. And we'll do a little bit of recapping. Thursday, we're going to have a quiz over 5-1 to 5-3. So that was the practice quiz we did last time. Remember? So let me get through one more kind of problem and then we'll do a couple more practice problems. Thursday, our next class. Alright, I am on section 5.4 now. Section 5.4. And I am going to solve equation number 5. Because I want you to see another application of these double and half angle identities. So this is, whoops, that's not quite right. This is question number 5 in 5.4. the directions say solve between 0 and 2 pi. So that means we want to find all of the x's, all of the angles that make this equation true in one revolution. All of them. Okay, so what are your thoughts when you see this problem? Knowing what you know right now, and I know you've never solved an equation like this before, but you do know some stuff. What might we do to get the ball rolling? Change this into what we know it is. What is sine 2x? Look at your sheet. 2 sine cosine. So very good. Step 1, if your equation has 2 x's and plain x's, get rid of the 2 x's using your formulas. All right, so that's exactly right. All right, now let's look at what we've got. Thoughts now. Dividing by 2 sine x is your natural instinct. It's what we want to do, and my golly, it would make this problem so much easier, but you can't. Never ever divide if your purpose is to cancel. And isn't that what you would do if you divided by 2 sine x? You would cancel. You would lose half the answers in the problem because you're canceling out a whole potential list of problems. Can't do it. Can't do it. Cannot divide if you're going to cancel. Okay, let me give you a quick example of when you could divide. Let's say you have this problem. I don't like that. If I divide both sides by cosine, is there still a cosine in my problem? Is it still there? I didn't lose it. That is okay. Over here, if you divided both sides by 2 sine, would there still be a sign in your problem? No. So if you're losing it, don't do it. If you're just moving it to the other side, that's okay. See the difference? Okay. All right, so we're not going to do that. So what are we going to do? If that's not legal, what are we going to do? Subtract it over. Whoever said that, you're a winner. Subtract it over. We like to have our equations equal to 0, don't we? The nice thing about having them equal to 0 is, it's just like back in, 7th grade. The nice thing about having it equal to 0 is, once you get them factored, what can you do with each of the factors? If it's set equal to 0, you could set them equal to 0, right? Well, I wonder if I could do something similar with this. Is it factorable?
Yeah.
What can you do? Take out a 2 sine. Don't forget, when you take out the whole thing, you have to have a placeholder 1 in there. Now, what's the beautiful thing about having it equal to 0? We can now take both of these things, both of these factors, and set them equal to 0. This equation says sine equals 0. This equation says cosine equals 1. Right? How are we going to figure out where that happens? Remember, you're looking all the way around the whole circle, the whole revolution. How do we figure out where the sine is 0? Sine is y over r. So it's impossible to draw a triangle with a side of 0, right? So I know I'm not even going to draw a triangle. I'm going to look around this whole circle, and I'm going to find all the places where the sine, which, as Taylor said, is y over r is 1, where does it happen that the sine is 0? On the x-axis. So this angle, which would be 0, and this angle, which would be 180 or pi, if we're doing it in radians. Now, if this has been a different problem, and we come up with sine equals 1/2, then we wouldn't be looking here, would we? If sine equals 1/2, what would I be doing? Drawing triangles in the appropriate quadrants. But we got 0. All right, now what about this? Where does the cosine equal 1? 1 in the same spot. The cosine equals 1 right here. Not over here. Over here the cosine equals -1. But this is the only place where x over r is 1. So, since I've already listed that answer, I won't list it again, and these are the two answers to the question. Ross?
Is it always going to have the directions to not include 360?
Yeah, because 360 is redundant. If 0 is an answer, 360 would automatically be an answer because they're coterminal. Okay?
So you answer 0.
0 and 180, both of those. You take whatever answers you get out of all the pieces of the problem. So we got 0, 180, and 0. So that's 0 and 180. All right? Well, we'll spend a little more time with this on Tuesday. What I want to do with our remaining few minutes here is practice a little bit more for our quiz on Thursday, which will not be a partner quiz, oh, by the way. You'll be on your own for that one. So in your packet, if you go to the 5th page, there's another quiz. Now, this is over 5.1 to 5.4, so there'll be part of it we won't do right now. Okay? We haven't speed dated yet, have we? We'll do that sometime. Cosine 285. Here we go. This is a potential quiz question on Monday. By the way, or I said Monday, Thursday. By the way, you will not have your green sheet. So since the quiz is over 5.1 to 5.3, you need to have your sum and difference identities learned by then. Okay, not the new ones we just talked about today, but the ones that we've been practicing. Sine, cosine, plus cosine, sine, those, okay? So here we go, cosine 285, step 1. I guarantee this is going to be a question. You're going to have to do something like this. Cosine 285.
Add up to
Yeah, what am I going to break that into?
45.
45 and 240, that's one option, a great option. 45 is obviously a good choice. 240 is a good choice because what's the reference angle for 240? 60. So we are all set on our angles. Notice I drew both of them because I know what's coming. I know I'm going to have to be plugging those numbers in, right? But into what? First I need my formula. Cosine 45, cosine 240, it's cosine minus sine. Right, so minus sine 45, sine 240. Everybody still with us? Know why we use that formula? Understand all the signs and everything in there? So now we just start plugging in. Cosine of 45, root 2 over 2. And so is the sine of 45, so I'm going to fill it in, those two match. Cosine 240, negative 1/2. And sine 240, negative root 3 over 2. So this is those kind where we have a 4 in the denominator because we have a 2 times 2. And what do we have up top? Negative root 2 plus root 6 because we have a minus. If you don't get an answer that looks something like that, you're probably wrong. Everybody okay with that? Any question about that? Okay, number 2 will not be on this quiz, so let's get down to number 3 because it will be, or could be, I should say, could be, cosine 270 minus x. What did Mrs. Ford tell you about when you see an angle minus an angle or an angle plus an angle? What should you immediately think of? Your formula. So here we go. What's this one? Cosine 270. Cosine x plus sine 270 sine x. Everybody okay with that formula choice? So now what do we do? We've done a couple like this already today. What do we do here? We figure out what, we gotta plug numbers in for right here, right? So 270 is special, it's down here. What's the cosine of 270? 0. And what's the sine of 270? Negative 1. So it looks like that just works out to be negative sine. Four is not on the quiz. Turn it over. The only ones that you're required at this point to know are 1 and 4. So what would 1 be a formula for? Cosine, not cosine 40, cosine 14. We add the angles. We add them, right? So number 1 is a formula for the cosine of 14. What about number 4? Tangent of 18. The rest of those are half and doubles, and we'll get those later. You're not responsible for having those memorized right now. All right, but you should be able to do this bonus down here, find the exact value of the sine of 75. Take a couple minutes. See if you can write the formula you use, draw the pictures you use, and then work it out. See if you can do that. Finding the exact sine of 75. I don't think that's going to be a bonus on your quiz. It's going to be a question. So you got to write the formula you use, draw the picture, and then work it out. take 75 down? Did you pick 45 and 30? Okay, you didn't have to, you know that, you could pick other things, but I think that's probably the most obvious. Whatever angles you picked, did you draw a picture of them? Labeling the sides so that you could get the numbers and plug them in. All right, what formula did you use for the sine of 45 plus 30? Sine 45 cosine 30 plus cosine 45 sine 30?
Yeah.
And then you took the numbers from the pictures and plugged them in. Did you get this answer right here? In some form. All right, you did not. Who has a question about something there? All right, here's what's gonna happen on Thursday, and I'll see you tomorrow. Thursday, we're gonna get back our identities quizzes that you just took earlier. We're gonna go through all three of them, because there were 3 different ones out there. We'll go through all 3 of them, so everybody can experience and practice those. And then we're gonna take a quiz over everything up through this stuff, 5-3. Okay, so there's no halves and no doubles, but everything else is fair game. Could be, since sections 5-1 and 5-2. No, it'll be a quiz, it's not gonna take all period. All right, everybody clear on what that expectation is? Your homework is gonna be due Monday, because we are getting close to being done right now. I mean, you could probably finish it right now. I have a few random questions. Homework will be due Monday. We'll spend one more day on 5-4, and then we'll start reviewing. So we're gonna have a test sometime next week over 5-1 to 5-4. Clear? All right, you're out of here. Run, dash. Don't kill each other as you try to get out of the room.